In this video, we'll talk about TCP/IP's transport mechanisms, TCP and UDP. TCP and UDP are protocols that apply to layer 4 of the OSI model. Higher level apps need some kind of a transport mechanism, and that comes in the form of either TCP or UDP. Usually, it's determined by the software developer, but some network services will allow admins to change whether the listening port number listens on TCP or UDP. TCP is the Transmission Control Protocol. It establishes a session with a target before transmitting any data. It's considered connection oriented because it sets up a three-way handshake before transmitting data. In packet number 1, the initiator sends what's called a SYN packet to the target. This means synchronize. It's used to synchronize sequence numbers, which are used to number the transmitted packets. Then the target will send back a SYN-ACK to acknowledge that, yes, we're going to agree on our starting sequence number. The sender, or the initiator, in number 3, then acknowledges the acknowledgement to the original SYN packet. After this has been completed, the connection is established and data may be transferred. However, what's interesting is that the sender will require an acknowledgement for each and every single packet that is sent. Because TCP, aside from being connection-oriented, is also a very careful and reliable protocol. Common TCP header fields include things that we might see within an HTTPS packet, such as the source port number. Now notice in our diagram, the source port number is 59,591. That's a pretty high-level port number, whereas the destination port number is HTTPS port 443. What this is telling us is that this is a transmission from a client web browser to a secured web server. Because secured web servers listen on port 443 but communicate back with clients on a higher level port, in this case 59,591. Now we can also see that there would be a sequence number which is tracked by both ends of the connection for the transmission of packets within the session. There's also the next sequence number, there's an acknowledgement number, and a checksum to ensure that what is received is what was sent. Now, from a security perspective, it's important to know these internal workings because a lot of malicious attacks take advantage of these, and they might use overlapping sequence numbers to crash a host. Or, as a matter of fact, a malicious user can actually forge every item within a packet. The payload, the headers, all of this stuff can be forged by a malicious user with freely available tools. UDP is the user datagram protocol. It's another transport mechanism besides TCP. It's considered connectionless, where TCP is connection-oriented. So therefore, with UDP, a session is not established before transmitting data. So in other words, it simply sends out the traffic and hopefully it gets received by the intended recipient. There's no checking. So the sender does not require an acknowledgement for every sent packet. So because there is no session per se with UDP, firewalls then treat every packet as a unique connection. UDP header fields are few compared to TCP. So in this case, we have a DNS query packet where the source port number is a high numbered port. Now remember, port numbers are also called layer 4 addresses. The destination port in this example is domain or UDP port 53. What this is telling us is that this is coming from a client device, so a higher source port destined to a DNS server. It's some kind of a DNS query. Now, we'll also see other fields such as the length of the transmission in bytes, so in this case 60, and a checksum value to ensure that what is received is what was sent. Now, it's important that we understand common TCP and UDP port numbers. Now, you might ask, why is this relevant? This is important because network scanning, which can be conducted legitimately or by malicious users for reconnaissance, can identify services based on the listening port number. Now, if a malicious user scans a network and sees port 25 on TCP, they're going to know that that's SMTP, and they might probe that further to discover the type of mail server you're running and then find vulnerabilities for it. So, on TCP, port 22 is for SSH, Secure Shell, which is used as a secured remote administration command line tool. Port 25 over TCP is for the Simple Mail Transport Protocol for transferring mail between mail servers on the internet. TCP port 80 is for HTTP web servers, TCP 443 secured HTTP web servers, TCP 3389 is used by remote desktop protocol to remotely administer Windows hosts. On the UDP side, we've got port 53, which is for DNS client queries going to a DNS server, and we also have UDP ports 67 and 68 used for DHCP when a client needs to acquire an IP configuration from a centralized DHCP server. Now, there are many, many other port numbers for different network services. This is just a tiny sampling. There's then the notion of stateful packet inspection. Stateful packet inspection devices can track packets belonging to a TCP session. So they know that a session is established and they don't treat each individual packet as a separate connection, as is the case with UDP. So that would be called stateless packet inspection, where the device is unaware of data transmission patterns. Now, in some cases, when you look at firewall solutions, be they hardware or software based, it might be a stateful packet inspection device or stateless. Ideally, we want a stateful packet inspection device that can do both. In this video, we discussed TCP and UDP.